Hey everyone, and welcome to videos for lesson 16. Today we're going to be talking about a few different things. First, we're going to be talking about creating our own functions. Then we'll talk about organizing our code and installing external packages. And we'll finish with some string formatting. This lesson is divided into 3 different parts. And I encourage you to take breaks between the videos in order to take care of yourselves along the way. Up first, we have creating our own functions. We're going to do this as a notebook demonstration. This lesson 16 notebook is available to you on the class Google Drive and linked on the class Canvas page. We're going to be using 6 different netcdf files, each of which corresponds to a single profile made by this float, number 5901109.5. That number doesn't matter too much, except you can see in the file names that these are all from the same float, and the profiles are number 185 up through 190. All of those files are available on the class Google Drive in the 2020-12-1 lesson 16 data folder. I encourage you to load those to your own drive and follow along as we go. First thing we want to do is our package management. Because these are netcdf files, we're going to be using xarray, which means we have to do our installation of netcdf4. So we say pip install netcdf4, and after we run it, we comment that back out, so we only run it once per notebook. And then we do our import statements. We're going to import numpy, xarray, and matplotlib. We're not doing any mapping, so we don't need to worry about cartopy stuff this time around. And then we want to mount our drive. When I run this, you'll see my drive is already mounted. Go ahead and pause, get your drive mounted, and get these files onto your drive. The files are on my drive, the my drive data folder Argo float data. And let's go ahead and just look at the very first file we have, which is number 185. Now to get the data from that, we're going to use xarray, and we say xr.open dataset, and we'll give it our file path and our file name. Go ahead and run it and take a look and see what we get. So we get something with 70 data variables. We're not going to care about all of those. All that we want are the temperature, the pressure, the longitude, and the latitude. Everything else is going to be extra. We're not going to be looking at them. You'll also notice that in the dimensions, there are these things with just ones next to them, and that means that there's only sort of one object in that dimension. That can tend to sort of confuse our structure when we're reading things, so we want to get rid of those singleton dimensions. To do that, we can use the squeeze function. We say data equals data.squeeze. And when we display that after squeezing it, you'll see that those dimensions are gone now. So now that we've gotten rid of those singleton dimensions, we can get our longitude and latitude. We'll say lon is equal to data, and in true xarray fashion, we say longitude. Notice that it's all in caps because that's a variable name. And we're going to set it as a numpy array, so we'll say values. And we'll do the same thing for our latitude, where we have lat equals data latitude.values, and we'll do the same thing for our temperature and pressure as well. And we'll run that, and we'll extract all of those things. Now, to look at this, we'll go ahead and look at our temperature data. So we'll say fig equals plt dot figure. We'll give it a fig size of 10 by 10. And we'll give it an axis object, so ax equals plt dot axes. And we'll go ahead and make a plot. So we'll say plt dot plot. And actually, we'll go ahead and say ax dot plot since we did create that axes object. We'll put our temperature on the x-axis and our pressure on the y-axis. And we'll plot and see what we get. You can see we get all of our data out of it, and it looks like a nice line. Now you can do all of the formatting things, change your line style and your invert your y-axis and everything. I'll go ahead and copy paste code for that. So we change our line style, we invert our axis, we set our labels, and when we run that, we get a figure that looks like this. Now, last thing we want to do when we have a nice figure is save it. So we say plt.savefig, and we'll call it T profile number 185, and we'll save it as a PNG. When we run this and open our file here, you can see it now has T profile number 185, and we open that and you can see this is the file that we just created. So that's really great. We have now looked at this one file, but what happens when we want to look at the rest of our files, right? We would either have to copy and paste all of this code, which, that's quite a large number of code. It's almost 30 lines each. Or we can create a function to do this same stuff over and over again, just changing our file name each time. When you want to do something more than 3 times in your code, it's best to use a function instead of copy and pasting it. So here we're going to do a function for reading our data, and we're going to create a function for plotting our data. Up first, we're going to create our function for reading. So to create a function, we use def, which is just defining our function. And then we give it our function name. For this one, we're going to call it prof get data. And that's just saying, for this profile, get the data. And we're going to put parentheses because we're creating this as a function. And inside the parentheses, we're going to want to give it our function arguments. For this case, we want to give it our file path and our file name. And in order to actually create our function, we put our colon and hit enter, and then we're going to create our function inside. We can actually copy and paste pretty much our exact same code from this cell here, right here in the tab there. So we have our open data set, we squeeze our data, and we get all of those values out. Now, this file path and file name are not actually this file path and file name. Instead, they are creating local variables. And that just means that these are the variables that get used inside of this function, but they don't apply anywhere else. So if you tried to create a file path in here and you wrote print file path under here, you wouldn't get the file path that was in here. The same thing goes for any variables you create in here. You can't get them while you're outside of the function. So in order to get those things when you're outside the function, you actually have to return those values. So we use the word return, and then we're going to return the values we want. So we want our temperature, our pressure, our longitude, and our latitude. And now when we run this, we actually don't do anything. All this is doing is saying, hey, Python, this is how you read the data when we give you this function. Now we want to give it some arguments and have it actually read the data. So we're going to give it the same file path and file name, and we're going to use our function, right? So we're going to say data, actually, we're going to use, so we're going to say tp lon and lat, because those are the objects we want out. So we want tp lon and lat is equal to our function name, prof get data, and we're going to give it our arguments, our file path, and our file name. And now if we print our temperature, you can see that it's now successfully extracted our temperature with just this one line of code. And the beautiful thing about creating this function is that now we can change this file name and just make it a 6 for reading number 6. And when we print the temperature on that, you can see it changes the temperature because it's reading the temperatures from profile number 186. So let's go ahead and create a for loop to read all of the temperatures from each of the files. So we'll say for index in range 0 to 6, right? Because there are 6 files. And we're actually going to create a list of our file names. So this is all of our file names, number 185 up to 190. And for this one, we'll just tab in for our loop. So we're going to go index in range 0 to 6. We'll say prof get data. Our file path doesn't change, but our file names are now going to be based on our index, right? So every time the loop goes around, it's going to choose a different one of these file names here. And we're going to print t for each of them. You can see this function here is now reading the temperature, pressure, longitude, and latitude for each of the files, and then we're printing it for each of the files. You can see now that the temperatures are changing for each of those files. Now say that we want to plot each of those. Well, we could copy and paste this 6 times, or we could copy and paste this into our for loop, but that would kind of make things a little bit more confusing. Why don't we go ahead and create a function to do the plotting? So we're going to say def, we're going to say prof plotting, and we'll feed it our temperature and our pressure. And why don't we go ahead and give it our color, and we're going to give it a default value. So we're going to say C is equal to black. That means that if you don't put in a color argument, its automatic is going to be black. And same thing with line width is going to be equal to 2. So the default value is a 2, right? And now we can use pretty much our same code from our plotting here. And just make sure that it's tabbed in to be in our function. So we're going to create a figure. We're going to create our axes object. We're going to plot our temperature and our P. And our color is now going to be C because we want to be able to change it. And our line width, we want to set as our line width from up here. And that's, remember, creating a local variable that we can use in here, but nowhere else will it be the same. Now you'll also see file name is something we use here, and it's better to not call on anything external. So we're actually going to create another argument of file name here. And that'll just be one of the files whenever we go through here. And we don't want to save it all as number 185 because that'll overwrite. So we'll save it as filename.split, and we'll do the same thing as our file that we're saving as our figure. So that's making our plot there. We run this, and we'll see that nothing happens. But now we can go through our loop here, and we're going to say, notice that nothing is returned, and we actually don't need to set anything equal to our function. We can just run it as prof plotting, and we give it our temperature that we just created in this, our pressure that we just created in this, and then we're going to give it our file name of index, because that is the different file names for each iteration of the loop. Now we run this, and we'll not print out those temperatures. And what we'll see is that it now creates a plot for each of the different profiles. You'll see that the title changes because we are now going off of a file name here. And you can see that they're all the different plots. So now we've created these plots, and we read the data with just 2 lines of code, which can be really helpful and powerful for if you have a lot of different files. So say instead of 6, we had all 190 profiles from this float. We could go through and say 0 to 190, and we would just go through and it would make plots for each one. And you can see that it's now saved it in all of this here. To review, we use def, we give it a function name, and then we give it whatever arguments that then create a local variable, which can only be used inside of our function. Then we do something inside of our function, and we return whatever variables we want. For here, for the plotting, we actually didn't need to return anything because inside of this function, it was creating those figures all along. So that ends it for our overview of creating new functions. Up next, we're going to be talking about organizing our code and installing external packages.